So we know that the equilibrium constant is temperature dependent and that it depends on delta H. So with all of this combined, we have a way to find the equilibrium constant at new temperatures. I'm going to give you two equations for this. There's a 1-point version and a 2-point version. So the 1-point version, the equation is the natural log of KEQ is equal to negative delta H reaction over R times 1 over T plus delta S reaction over R. Now that you would probably want to combine this in some other way if you were solving it, but it's in this form because it goes with Y, M, X, and B. This is a straight line equation. So the way that this equation would typically get used is that you would collect a bunch of data, make a plot, fit a linear trend line to it, and then the equation of that trend line would be this equation. So you would then be able to use the equation for the trend line to go in and find at any temperature that you did not collect data for, what would the equilibrium constant be? You can also use it to find the delta S for a reaction. You could find the delta H for a reaction if you knew the other two values. This is probably the more accurate version of the equation. We just don't often enough have that much data to work with. So if you took 2 points from that trend line and you put them together, that is this last equation that's resulting. It's a 2-point equation. It's less accurate, but we're going to use it more often because we usually just have enough information for this 2-point equation. So the 2-point equation, the natural log of K2 over K1, so equilibrium constant 2 over equilibrium constant 1, is equal to negative delta H reaction over R times 1 over T2, so the temperature that goes with K2, minus 1 over T1.